Geochemical Characterization and Provenance Study of Ilmenites from Fluvial Sediments of River Cauvery in parts of Tamil-Nadu, southern India. Abstract: the Cauvery River is the third longest flowing river in South India. This river flows through three southern Indian states, Karnataka, Tamil Nadu, and Puducherry. The river Cauvery takes its birth at a place called Talacauvery in the state of Karnataka, and after a long journey of 800 km from the Western-Ghats finally forms a delta and joins the Bay of Bengal in the east. This river traverses high-grade metamorphic rocks. Ilmenites are good indicators of provenance, and several researchers throughout the globe have contributed on this aspect. The present study is focused on chemical characterization of the detrital ilmenite from the fluvial sediments of downstream of the river Cauvery. The TiO2 content of ilmenites varies from 46.42 to 51.28 Wt%, whereas iron oxide values range between 46.35 to 50.68 weight%. The detrital ilmenite grains are primary in nature and not subject to any alteration. Bychemistry: we can conclude that basic suites are source for the ilmenites in fluvial sediments of river Cauvery. Keywords: ilmenite, Cauvery, provenance, Precambrian rocks, southern granulite terrain, fluvial sediments. Introduction. Heavy minerals are pathfinders for provenance. Various heavy minerals such as garnet, zircon, and amphibole are found along the upper reaches of the river Cauvery and its tributary river Cauvery. Prakash Narasimha et al., 2018. Ilmenite generally occurs in a wide variety of igneous rocks, both intrusive and extrusive, as well as pegmatite and other vein rocks, and even some metamorphic rocks, especially gneiss, Ramdar, 1980. Previous studies of detrital ilmenite also suggest that the variation in its element content is sufficient to provide an unmistakable signature to determine sediment source, Darby et al., 1985. Detrital ilmenite is commonly present as a large part of sand particles, Pettijohn et al., 1987. Several researchers worked on the ilmenites across the global level to understand the source from the geochemistry of ilmenites, Hedge et al., 2006, Sukumaran et al., 1994, Grigsby, 1992. The present study is aimed at chemical characterization and provenance of the detrital ilmenite from the fluvial sediments from downstream of the river Cauvery. Study area. Cauvery River is an easterly flowing river of the peninsular India that runs across three of the southern Indian states, Karnataka, Tamil Nadu, Puducherry. The third largest river of southern region, begins its 800 km long journey from the Western Ghats, traverses through Mysore Plateau and finally forms a delta on the eastern coastline of the subcontinent, Pumpuhar, before falling into the Bay of Bengal. The Cauvery River basin lies between latitude 10 degrees 09 N to 13 degrees 30 minutes north and longitude 75 degrees 27 minutes east and 79 degrees 54 minutes east. The lithological units along the course of river Cauvery comprises of Precambrian rocks, principally the gneiss, granulite, laterite, and tertiary sediments, Pichimuthu, 1978. In the upper and middle part, the river drains through granitoids, gneisses, granulite, and ancient supracrustal belts composed of metaigneous, metasedimentary rocks, and carbonate rocks, Ramakrishna and Swaminath, 1981, Prakash Narasimha et al., 2009, Pichimuthu, 1976. The lower part of the river basin is underlined by Cretaceous sediments, Sundaram and Rao 1981, Subramanian and Selvin 2001. Methodology. The sediment samples were collected from the river from 8 locations at an interval of 60 km along the course of Tamil Nadu part of river Cauvery. Cone and quartering method, pouring the sediment samples so that it takes on conical shape, and then flattering it into plain cake. The cake dividing into quarter, the 2 quarter which sit opposite one another are discarded, while the other 2 are combined and constitute the reduced sample, were employed to collect sediment samples. About 500 grams of sediment sample was collected at 8 locations along the course of the river Indiana parts of Tamil Nadu at an interval of around 60 km, Figure 1. Collected samples were dried and then subjected to the sieving in the sieve sizes of 60, 120, and 180 micron mesh. The 120 microns mesh-sized sample was selected for heavy mineral separation by gravity method using heavy liquids. Ilmenites were separated with the help of stereo binocular microscope. These minerals were mounted on the slide with the help of epoxy and slightly polished and then subjected for the EPMA analysis at PPOD Lab, Geological Survey of India, Bangalore, India using camera SX100 EPMA instrument. Results and discussion. The chemistry of the ilmenite grain which were determined are shown in Table 1 and based on 2 oxygen atom structure, has been calculated. The TiO2 and FeO concentration of ilmenite ranges from 46.42 to 52.18 Wt%, and 46.35 to 50.68 Wt% respectively. Primary ilmenite refers to unaltered grains, with composition close to the stoichiometry defined by the formula FeTiO3, where TiO2 content varies in between 48 and 53 weight%. The trilinear plot of FeO Fe2O3TO2, Fig. 0.3, and scatter plot, Figure 0.4a, can be inferred to show that ilmenites along the course are unaltered to slightly altered, Figure 0.2. The manganese concentration is higher in grains containing 45 to 50 weight% TiO2, Fig. 0.4b. The MnO content of ilmenite ranges from 0.8% to 1.91%, and the MgO concentration varies from 0.07 to 0.85%. Magnesium is showing higher concentration when TiO2 concentration ranges between 50 to 55 weight% except in sample C5. This is due to the presence of magnesium-rich rocks in the sampling site, Fig. 4c. The scatter plot, Fig. 4d, of MnO versus MgO represents the trend in such a way that there is an increase in MgO along with decrease in MnO in ilmenites. This indicates that the source might be basic rocks present in the drainage basin. End-member compositions plotted on FeTiO3 MnTiO3 MgTiO3 Fe2O3 system, modified by Nayak and Mohapatra, 1998, fall towards the ilmenite apex of the basic suites, Fig. 0.5. The amounts of Al2O3, 0.01 to 0.04%, Cr2O3, 0.02 to 0.1%, are recorded along the course of the river. The TiO2 concentration of ilmenite indicates that the sources of ilmenites are high-grade metamorphic rocks. An ilmenite grain with TiO2 content between 50 to 60% indicates their metamorphic origin for the ilmenites, Basu and Molinaroli, 1991. Conclusion. The chemistry of ilmenite grains indicates that rocks like metabasic suites are the major source for the ilmenites in the fluvial sediments of River Cauvery. Acknowledgement. The authors are grateful to NSES, Kerala for their help. The authors are thankful to the ISRO/NRSC for the financial support in the form of research project for this work. We are grateful to Professor, SMT, KG Ashamanjari Chairperson, DOS in Earth Science, University of Mysore, Mysuru for his help and encouragement.